Welcome back to our fourth and final video in the mini series on understanding limiting reactants. In this final video, we're going to explore how we can use the mole-to-mole conversion concept to determine how much product we're going to form given an initial amount of two reactants, but this time the amount of reactants is going to be given to us in mass quantities, in this case grams. So we're going to proceed towards a solution following the same protocol we have been in the previous videos, but now we're going to be starting off with our initial amount of reactants given to us in our gram quantities. So I'm going to start off by writing down how much oxygen and how much hydrogen we have. All right. So we have 5.3 grams of oxygen, 2.5 grams of hydrogen. Now, our pathway is basically to figure out if I were to hypothetically react all of my oxygen molecules here, we'll want to figure out how much water we can form, do the same thing for hydrogen, and then once again take the smallest quantity at the end. Okay? But now we've got a little bit of a problem. When we are carrying out our mole-to-mole conversions like we did in the previous video, that relied on being in units of moles because our balanced chemical reaction equation gives us relative amounts of reactants and products in units of moles. Right now we're in units of grams. So before we do anything involving a mole-to-mole conversion, we need to first convert our gram units into units of moles. So to do that, we're going to use our good old friend, the molar mass. So the molar mass of oxygen, in this case, remember we've got O2, is going to come out to something about 31.998 grams of oxygen for every 1 mole of oxygen gas. All right? And remember, a common mistake that I will see students make is say, hey, I'm dealing with oxygen, so they'll just take the mass of 1 oxygen atom, right? But you have to remember we've got that subscript of 2 on there. So in remembering that proper molar mass, we've now converted from units of grams into units of moles. Now we were exactly in the same spot we were in the previous video. We can now use the mole-to-mole conversions to take our moles of oxygen reactant into our moles of product using these stoichiometric coefficients and the ratio formed from them. So our moles of oxygen here, we have a 1, right, so 1 mole of O2, okay, is required for every 2 moles of H2O. Okay, now, at the end of the day here, at this point, we've got moles of water, okay? And stopping here at moles of water would give us the correct final answer in terms of how much product we're going to form. However, the question is asking us to determine how many grams of water, so we're going to go ahead and do a final conversion here, taking us from moles of water into grams of water, which once again is going to rely on our molar mass. So the molar mass of water in this case is approximately 18.015 grams of water. So grams H2O for every 1 mole of H2O. 1 mole H2O. Okay. Now, I'm going to give myself a little bit more room here. If we carry out this calculation, plug it into the calculator, we will end up with a value of approximately 22 grams of H2O. Now, we're going to do the exact same thing with our initial quantity of oxygen here, of H2 here. So now if I'm going to kind of go back through here and go look at the initial problem, I've got 2.5 grams of this H2 starting material. Okay, so I believe actually I'm looking at my notes here. I apologize. If you plug this into the calculator, you should end up with a value of 3.0. All right, so make sure that you guys can double check that, right? So we've got 3 grams of water that's being formed if we use up all of our oxygen, right? And right down here, now we're going to be carrying out the same steps essentially for our initial mass of H2. Okay, so once again, we're going to come through. we need to first, if we're going to carry out a multimole conversion, we need to get into units of moles. So we're going to use our mass, molecular mass of H2. In this case, H2 has a molecular mass of about 2.016 grams of H2 for every 1 mole of H2. Now, once I'm in units of moles of H2, again, proceeding as we did in the previous video, we can directly carry out that mole-to-mole conversion. In this case, the mole-to-mole ratio, once again, is going to be 2 to 2, because there's exactly 2 moles of water that are formed from every 2 moles of H2O that's formed. So we get 2 moles of H2O that's formed for every 2 moles of hydrogen gas that's used up in the course of the reaction. So now we are essentially at the same stage here. Our final step is going to be doing a conversion into our desired units, because at the end of the day, we want to know how many grams of product we're going to be forming. And we are going to then just multiply by our molar mass of water in this case. Okay. And so we have this many grams of H2O for every mole H2O. Okay. Now this one, if we plug it into the calculator, you should come up with a mass of approximately 22 grams of H2O. And we're all set to now compare the relative value of these two quantities. And obviously the 3 grams is much smaller than that 22 grams. So the 3 grams of H2O is in fact going to be our theoretical yield. Theoretical yield for the reaction. And of course, the oxygen is going to be our limiting reactant. That concludes our mini-series on Introduction to Limiting Reactants and using these mole-to-mole conversions. The further videos will be basically going through some sample problems, some sample exercises.